Imagine a car so affordable, it costs less than a new iPhone, yet it's built by Tesla. Elon Musk just shocked the entire auto industry with the Tesla Model 2, a $15,990 EV that could replace millions of gas cars forever. But here's the twist. Tesla never wanted you to know how close this car really is. Until now. Across the US, a 400 to 500 mile trip still eats up 6 to 7 hours by car, and short-haul flights covering that distance, they still average nearly $397, with turboprop cabins often blasting passengers with 85 to 95 decibels of noise. To make matters worse, only about 73% of those flights arrive on time, with delays caused by late aircraft and ongoing maintenance. Regional travel has become noisy, slow, and expensive. But what if there were another way to cover that distance just as fast as a plane, while keeping costs low and skipping the usual hassles? Elon Musk's 2026 Tesla super electric plane might just be the answer. With hot swap battery packs that slash turnaround times 2 minutes, and distributed electric motors that stay whisper quiet while ensuring reliability even if one fails. This could redefine short-haul aviation. If you're tired of endless delays and long lines, subscribe to Road Zone Reviews. Help us hit 169,387 subscribers and tap the bell so you never miss an update. Tesla super electric plane cabin layout. The fix for regional travel. The mission is simple. A flexible 4 to 12 seat cabin that's easy to maintain, quick to board, and quiet for short hops. To begin with, 4 and 6 seat layouts are perfect for everyday family travel. A single aisle setup with about 20 inches of width and 33 to 34 inches of seat pitch gives older adults and kids easy movement. Seat widths between 18 to 19 inches remain comfortable on 45 to 90-minute flights, with baggage stored neatly under seats and in the aft compartment, meaning no bulky overhead bins are required when capacity matters. 8 to 12 seats are arranged in a 1 to 2 configuration with tighter geometry. Seat pitch adjusts to 31 to 32 inches with an 18 to 19-inch aisle for 8 seats, or 30 to 31 inches with an 18-inch aisle for 10 to 12 seats, combined with a 28 to 32-inch low-step door. These layouts speed up boarding, improve turnaround efficiency at smaller airports, and lower the cost per seat on 60 to 120-minute flights. For trips when seats aren't the priority, Combi mode blends passengers and cargo, with 4 to 6 seats up front and cargo in the rear. A lightweight bulkhead and standard tie-downs allow conversion in under an hour. Safety comes built-in with smoke and heat sensors, floor path lighting, and large print placards for seniors and kids. For larger layouts, a compact lavatory can be fitted and removed as needed. Every interior detail is designed for efficiency. A flat vinyl floor resists moisture. Modular wall panels swap in minutes, and seats use quick-release latches for rapid reconfiguration. Every seat includes USB-A and USB-C ports, while zoned HVAC keeps cabin humidity and temperature stable. By trimming or eliminating overhead bins, weight is reduced, and more room opens in the aft compartment for strollers, sports, gear, or hard cases. Which setup works best for you? Comment A for the 4 to 6 seat spacious layout, or B for the 8 to 12 seat option for larger groups. Propulsion stack, quiet, reliable, and easy to maintain instead of one large engine. Tesla's super electric plane uses multiple smaller electric motors, creating built-in redundancy while eliminating gearboxes, the main maintenance burden on turboprops. Each motor is powered by its own high-efficiency silicon carbide inverter, and if one fails, only a fraction of thrust is lost while the aircraft continues safely to landing. Modern SiC controllers have demonstrated up to 98.3% efficiency at around 14 kilowatts with a mass of just 1 kilogram, keeping the system compact and light. Smaller propellers spin at slower tip speeds, around or below 140 meters per second to reduce the harsh whine that makes short flights tiring. Distributed propulsion also improves takeoff and landing performance, energizing airflow more evenly across the wing. Power architecture is equally robust. 2 independent DC buses, linked by smart contactors, isolate faults in milliseconds. Either bus can run the motors, with cross-tie capability if needed. Essential Avionics have dedicated DC-DC converters and backup batteries that keep radios and navigation running even if both converters fail. This design reduces cabin noise compared to turboprops, which average 88 decibels at takeoff and 81 decibels in cruise. Distributed electric propellers can cut cruise noise to the mid-70s to 80 decibels. Maintenance also shifts to condition-based servicing, meaning small issues like warming connectors or worn bearings are detected and swapped proactively, preventing last-minute gate failures. Many motors mean quieter flights, safer redundancy, and fewer surprises. Comment Tesla's Super E-plane if you think this is the future of short-haul travel. They said Tesla couldn't make an EV this cheap without cutting corners. But when you look closer at the gigapress technology and Tesla's secret manufacturing shortcuts, you'll realize this isn't just another car, it's a direct threat to Toyota, Valeo, and even BYD. And wait until you hear how fast pre-orders sold out. Asterisk Energy Core. Built for fast turns and long life, the energy system is built around modularity. Instead of one giant battery, Tesla splits it into 12 to 16 blocks, each with its own sensors and fuses. If one block fails, it's isolated immediately, while the rest keep running, with only minor impact to range or power, instead of slow charging. The aircraft uses battery swapping. Ground crews slide packs in and out via rail and latch systems in just 5 to 10 minutes. That means a plane can complete up to 7 to 8 flights per day, compared to 3 to 4 with charging downtime. Swapping also keeps costs per seat low by maximizing utilization. Thermal management is equally vital. Liquid-cooled cold plates, short coolant loops, and multiple sensors hold cells at Y-35 degrees Celsius, with less than 5 degrees Celsius variation across the pack. This stability prevents rapid aging, extends battery life, and avoids sudden range loss in extreme weather. The battery management system BMS works like a digital co-pilot. Instead of raw data, pilots see clear range rings that account for weather, payload, and reserves. The BMS limits power output if cells are cold or fully charged, then relaxes restrictions in cruise. 2 high-voltage buses feed the motors, with backups for avionics and independent small batteries keeping radios alive in any fault scenario. Comment Tesla wins if you believe no airline could compete with this breakthrough. Avionics and safety comes safe. And always on time. Tesla's electric plane features a smart flight computer that constantly monitors weather, winds, terrain, and payload. It calculates real-time range and energy-efficient routes, displaying live range rings to the crew. Automation further boosts safety with an automatic landing system that selects runways, flies stabilized approaches, and even brakes after touch via one guarded button. The electrical backbone is equally resilient. Modular battery packs, dual buses, and cross ties ensure no single fault ends a flight. Essential systems ride on their own converters, with independent backup batteries protecting radios and navigation. Flight controls have redundant actuators and computers that cross-check each other, filtering errors instantly. Maintenance is simplified too. Each motor, inverter, and battery module streams health data in real time. Technicians swap faulty parts between flights using modular latches, keyed connectors, and quick-release systems. Planned quick swaps prevent surprises and keep flights on schedule. Service and maintenance at small airport servicing is designed for simplicity. Battery swaps take just 5 to 10 minutes with basic tools like pallet jacks or forklifts. Packs are aligned with guide rails, locked with safety latches, and connected with drip-free coolant couplers. A full turnaround, including passengers and baggage. Targets just 10 to 12 minutes. Condition-based maintenance adds further reliability. Motors, inverters, and batteries are modular and sized for 2-person handling. A motor inverter swap takes about an hour, a coolant pump under 30 minutes, and cabin panels just minutes. Training is minimal. New technicians can be certified in under 16 hours. And refresh with short updates. Safety is reinforced through simple high-voltage lockout procedures, one-page checklists, and routine drills. Suspected battery issues are isolated in vented cabinets monitored by thermal cameras. This modular, repeatable approach means even small airports can service the aircraft without exotic tools or long downtime. Asterisk. Most people watching this will think the Model 2 is just a budget car, but they're wrong. What's hidden inside this $15,990 EV could change how every future Tesla is built. The real story isn't about affordability, it's about domination. And that's exactly why competitors are panicking right now. Finally, that's the Tesla super electric plane built for rapid turnarounds, quiet cabins, and reliable schedules. If this vision excites you, share it with someone tired of regional flight delays. And don't forget to subscribe to Road Zone Reviews and hit the bell for more deep dive updates coming soon.